Seamless steel tube production relies on two primary raw materials, iron ore and carefully selected scrap. The first stage is the direct reduction process. Iron ore is charged at the top of the reduction furnace, where it moves downward by gravity and is kept for about 4 hours. During this period, a continuous flow of reducing gases, mainly a mixture of hydrogen and carbon monoxide, is injected. These gases react chemically with the ore, removing its oxygen content and converting it into direct reduced iron, commonly known as sponge iron. The ore enters the furnace at ambient temperature with roughly 67% iron content. Inside the reactor, it is heated to around 960 degrees Celsius. By the time it exits, its metallization degree reaches approximately 95%, before cooling back to room temperature. To efficiently recycle the selected scrap and integrate it with the direct reduced iron produced in the previous stage, the steelmaking furnace is charged in 2 steps. The first step involves adding carefully selected scrap. These furnaces have a total charging capacity of about 105 tons. The scrap is melted and transformed into a uniform liquid bath through the combined input of electrical energy and the injection of oxygen and methane, which accelerate melting and promote oxidation of undesirable elements. In the second stage, the charge is completed by continuously feeding direct reduced iron, sponge iron. During this phase, the bath reaches operating temperatures of approximately 1,650 degrees Celsius. The process requires an electrical power input of around 90 MVA to maintain stable melting and refining conditions. After slag removal, about 80 tons of molten steel are tapped into a ladle and transported to the refining station. There, electrical energy is used to maintain temperature while alloying elements are added to meet the customer-specified chemical composition. Automated process control systems, supported by central laboratory analyses, ensure that the steel's composition and cleanliness comply with quality requirements. The molten steel is delivered to the continuous casting machine, where the ladle pours its charge into a tundish that distributes the flow uniformly into the molds. These molds solidify the steel into round solid billets with diameters ranging from 148 mm to 310 mm, and annual production exceeds 1,200,000 tons of billets. Each billet is marked with an identification number punched on one end, ensuring full traceability throughout the subsequent manufacturing and inspection processes. To begin the rolling process, the cast billets are cut into shorter sections, known as billets, which are then fed into the rotary hearth furnace. This furnace is fired with natural gas and measuring about 48 meters in outer diameter, uniformly heats the billets as they complete one full revolution. Depending on their length and diameter, the heating cycle lasts between 2 and 4 hours, bringing the billets to an exit temperature of approximately 1,250 degrees Celsius. Once the required temperature is achieved, the billets enter the piercing mill for the first stage of hot deformation. Here, they are gripped by 2 skew-mounted conical rolls that force the material forward over a piercing plug, initiating the internal cavity and creating a hollow shell known as the pierced billet. This intermediate product then continues to the second rolling stage. A mandrel is inserted to support and size the internal diameter, while the hollow shell passes through several pairs of rolls that progressively reduce the wall thickness. Process accuracy is ensured by continuous online measurement of wall thickness is taken around the tube at multiple longitudinal positions to guarantee uniform wall thickness. The semi-finished tubes then reach the third rolling stage, passing through groups of 3 calibration rolls that refine the outer diameter and final geometry. Through this controlled multi-stage process, up to 18,000 tubes per day are produced with excellent dimensional accuracy. The finished seamless tubes can be used in many applications such as the oil and gas industry, either in offshore production, onshore production, or pipelines. Petrochemical and energy generation industries. In mechanical and automotive industry. Hydraulic cylinders. Car parts. In other industries. Metallic structures. Lighting columns. Gas cylinders. Thank you for watching this detailed look at seamless tube production. I hope this explanation helped you understand each stage of the process more clearly. If you enjoyed the video or learned something new, please support the channel by subscribing, liking, and sharing it with others who may find it useful. Your engagement helps the channel grow and allows me to keep creating high-quality engineering content. See you in the next video.